All right, solving logarithmic equations. These actually are kind of fun to solve. So Condensing's logarithm, use the one-to-one property, and that property says that if log base b of m equals log base b of n, so the bases are the same, then you can just set m equal to n. Okay, and you always have to solve and check for extraneous solutions. And in this case, this means that you cannot have a negative in the logarithm. So no negatives, write that down. Okay, extraneous solutions means no negatives. You cannot take the logarithm of a negative number. Okay, because logs are the answers to exponentials and something to do with that. I lost my train of thought. I will get it back, but basically no negatives, all right? So let's get into this. So we have log base 5 of 5x plus 9 equals log base 5 of 6x. We have the same bases, so we're just going to cancel those, and you get 5x plus 9 equals 6x. Solve for x, so x equals 9. Then we're checking for extraneous solutions, which means you cannot have a negative. So you have to plug it back in, blah, blah, blah. So 5 times 9 plus 9 is 54. 6 times 9 is 54, so that works. Okay, and those should also always be equal to each other. Let's do this one. So we have log of 4 plus, or y plus 4 plus log of 4 equals log of 72. Well, let's condense that on the left to become one logarithm. Addition goes with multiplication. So that's log 4 of y plus 4 equals log of 72. Drop those logs, or distribute that 4 in, so you get 4y plus 16. Now we can drop those logs, and you get 4y plus 16 equals 72. Subtract that 16, y equals 56. Divide by 4, y equals 14. Plug it in to check, and it works. I only plugged it into the y plus 4 because that's the only place where we had a y. Okay? Let's do this one. So log base 6 of 25, or 1/2 log base 6 of 25 equals log base 6 of 23 minus 4w. Now 25, we're going to move that 1/2 so it becomes a power. Anything raised to the 1/2 power is the same as square rooting it. So that's going to be the square root of 25, which equals 5. So log base 6 of 5 equals log base 6 of 23 minus 4w. Drop those, so you get 5 equals 23 minus 4w. Subtract that 23, negative 18 equals negative 4w. Divide by negative 4, so you get 18 over 4, which is 9/2. Plug it in, make sure you don't get a negative. You get 5, which is right, so we're good. It's positive. Okay. Now, ways to do it when you don't have two logarithms that are set equal to each other. So we have log base 2 of x minus 4 equals 6. Well, I'm just going to change this to an exponential. So you have 2 to the 6 equals x plus 4. Well, 2 to the 6 is 64, so 64 equals x minus 4. Sorry, I've been saying plus, x minus 4. Add that 4 over, and x equals 68. Check for extraneous solutions, plug it in, you get a positive, so we're good. This one, so we have log base 3 of 4x plus 8 minus 7 equals negative 3. Now I need this to be just by itself. I need the log to be by itself, so I'm going to add that 7 over. You get log base 3 of 4x plus 8 equals 4. Change that to an exponential. 3 to the 4th equals 4x plus 8, which is 81 equals 4x plus 8. Subtract that 8 over. 73 equals 4x. Divide by 4, and you get x equals 73/4. Cool? Check. You do get 81, which is positive, so we're good. When you check, just plug that straight into your calculator. Okay? You can do it in your head if you want, and that's super awesome, but we also have calculators, so you might as well utilize them. Okay? Now this one, we have log of 2x plus log of x minus 5 equals 2. We'll combine those, and you get log of 2x times x minus 5 equals 2, which is 2x squared minus 10x. And remember, if the log doesn't have a base, it's assumed that it's a 10. So this is 10 squared equals 2x squared minus 10x, which is 100 equals 2x squared minus 10x. Subtract that 100 over, so you get 2x squared minus 10x minus 100. And then we have to solve that. So I'm going to divide everything by 2 because 2 goes into everything. So you get 0 equals x squared minus 5x minus 50, which factors to x minus 10, x plus 5. So x minus 10 equals 0, x plus 5 equals 0. So x equals 10 and x equals negative 5. Then we need to plug them in, make sure we don't get negatives. So when I plug that in, there's no negative, so we're good. Plug in negative 5, we do get negative 10. Which means negative 5 does not work. So 10 is our only solution there. Okay, let's look at this one. So now we're getting into solving LNs, which is the same exact process. Don't let that intimidate you. Cancel those, so you get 4x minus 27 equals 15 minus 2x. Solve that, 6x equals 42, x equals 7. We still have to check, and they are both positive, so we're good. Do this one. So we have to combine first. So subtraction goes with division. Addition goes with multiplication. So 72 divided by 4, 6 times a minus 2. Well, 72 divided by 4 is 18, and that becomes 6a minus 12. Now you can cancel those. So you get 18 equals 6a minus 12. Add the 12 over, 30 equals 6a, and a equals 5. Plug it in to check. It's good. So that is our answer. Okay, this one, so we have ln 8x equals 2. Well, that's the same as log base e of 8x equals 2. Change it to an exponential, so e squared equals 8x. E squared in your calculator, it's second division key. So second, and then there's a teeny little e above that. If you have the same calculator that we use in class, that's what it is. So e squared is 7.3891, and it keeps going, so that's why I put the squiggly equal sign, because I rounded that, equals 8x, divide by 8, so you get x is approximately 0.9236. Okay, check, plug it in, you get a positive, so we're good. Let's do this one. So if we're solving this, I'm going to change that to a logarithm, okay? So this is going to be log base e of 57 equals x. Well, that's ln of 57 equals x. Put the ln of 57 in your calculator, and you get approximately 4.0431. Cool? Let's do this one. So first I need to get the e by itself. So I'm going to divide by that 5. So you get e to the 4n equals 19. Which is ln of 19 equals 4n if you change that. So if we do this L right there. ln of 19 is 2.9444, and that's approximately 4n. Divide by 4, so you get n is approximately 0.7361. Cool? Remember to take the quiz. Thanks. I don't know why I wrote it that way. Anyways, you guys are super awesome. Miss G out. Okay, I'm kidding. Okay, bye.